My name is Dr. Bihari Nandan Pandey, and today I'm just recording this lecture for complex topic in compiler design. In that sequence, earlier I have just recorded the lecture of first unit related to the topic of lexical analyzer. Today I'm talking about simply top-down parser. So you are aware that the whole particular compilation process is divided into phases, and these phases basically convert the source program into machine code, which is just getting fed into execution part, and we are getting the output. So if you are seeing that in that part, the second phase is syntax analysis, which receive the input from lexical analysis, that is tokens, and generate parse tree. And it is very significant part of the compilation process, because the whole computational values or elements has been just converted into tree form, so that we will able to find out the computational part which is going to executed by the machine code. So I'm covering these top-down parsing, predictive parser, non-recursive descent parser, and LL1 parser. So initially I'm giving the introduction of top-down parser. The parse tree is created to top to bottom. We have to start with the start symbol, and then we have to reach up to the accepted string of the grammar. So this is the process. The top-down parser is attempt to design the particular tree or construct the tree from top to bottom. If you're talking about top-down parser, we have two approaches. One is recursive descent parsing, second one is predictive parsing. In recursive descent parsing, we are giving the approach of backtracking. We'll be just relax that we allow the backtracking process in that. But in predictive parser, there is no backtracking, no left recursion. There is no problem with the grammar. So these two approaches, recursive descent parsing is very weak parser. We are discussing very rarely. It is not widely used. It is a general parsing technique, and it is not widely used. But predictive parsing is very important, and it is used for all the particular grammar which is executed by this grammar, this particular predictive parsing. So predictive parsing is called LL1 grammar. Why it is called LL1? LL1. One is basically look ahead. First L is left to right scanning, because we are using left to right scanning. And second L is leftmost derivation. So this LL1 is the name of this predictive parser. Means you can say that the grammar is LL1. The particular context-free grammar is LL1 when it is parsed by predictive parsing. So it is very important parsing. We will see the details of this parser. So recursive descent parsing uses backtracking, because backtracking is allowed. You will see in this process, you will find that this grammar is given S produces ABC, and you will see that B produces BC by B. If you are talking about this, B produces BC by B, this particular grammar, you will see that here backtracking is there. So some manual change will be required, because if you are moving, because whenever you are getting the B input as current input symbol, you have two choices. Either you have to move B, convert B into small bc, or to convert small b. But you cannot know, you are not aware about that, which particular production is able to generate the given language. So that is the problem. So here some manual process is there. If you are suppose selecting BC and you are getting that after some time, you are not getting to reach for ABC, and you will find that this is wrong selection. So then you have to backtrack. So this backtracking is allowed in that. So backtracking is needed for this recursive descent parsing. If you are talking about predictive parser, so whenever you are performing this predictive parser, you must check the grammar for the problems if it has backtracking problem or left recursion problem. So you cannot fit that grammar which have these two kinds of things. Means if the grammar is backtracking, production have, and if the grammar have left recursion production, you cannot fit, or this grammar is not suitable for predictive parsing. Then what you have to do? The first most important thing that is called, when you are starting to execute the predictive parser, you have to check in the grammar, either there are backtracking problem is there or left recursion problem is there. If both problem you will find, firstly you have to eliminate those problems. So first important thing for making the grammar LL1 for parsing or for the process of predictive parser, firstly you have to eliminate these two problems from the given grammar. Okay, so that is very important part for that if you are talking about predictive parser. So here some example is given, statement greater than equals to if, while, begin, for, that is the kind of CFG, because we are using CFG for context free for this syntax analysis, because CFG is very suitable because it has ambiguity features, and through ambiguity we are getting number of scopes for assessing the grammar. That's why it is very suitable. So the most important thing, firstly you have to eliminate the left recursion from the given production and eliminate the backtracking from the given production. These two requirements is there when you are feeding the grammar for the predictive parser. So if you are talking about recursive predictive parser, each notch terminal correspond to a procedure. A produces ABB. This is only the production rule for a procedure. A means every particular left hand side is called basically procedure. There is token, that right hand side projection is called basically token. If you are talking about procedure A, you will see that the derivative is ABB. So what do you do? Initially A match the current input symbol, then call B, because B is a non-terminal. When we are talking about non-terminal, it is a procedure. Then again we have to match small b and then call A. Okay, if you are getting that, then procedure A will be BAB and ABB. So initially input is accessible, then procedure have to be called, then again input is accessible. We are using epsilon productions also, if some epsilon productions are there, because we are using this context free grammar. A produces alpha. So alpha is what? Alpha belongs to V union T closure, because it takes context free grammar. So epsilon are also there. If epsilon is there, you will use that current input token is nothing. If nothing, then we are using the dollar, that is right hand marker or bottom hand marker. Through dollar we are accessing all the things. So a lot of concepts is in recursive descent parsing. So this is the basic process. If one algorithm, one particular grammar is given, then how to proceed for that. Now we have to talk about this LL1 parser. Okay, now, so this is the procedure for that. So it is given in this form. There is a parsing table. This is predictive parser area. Here predictive parsing table. One non-recursive program is used. There is input buffer. So input buffer is what? A plus B dollar. That is basically right hand marker. Basically we are using, because why we are using these markers? So that we will be able to complete the process and indicate that the process has been completed. In a stack we are using a stack structure in which the elements are grammar symbols, because and last bottom end marker. You will see that X, Y, Z basically belongs with one length, terminal or non-terminal, because in a stack everything is there. So whatever process is there, that depends upon the current stack symbol and current input symbol, the top of the stack and input symbol. So if it is capital X and it is a small a, then the combination of both, because we will derive a parsing table which have this X and capital A. Okay, so for finding that combination, we have to find out some 2-3 combinations are there, and through that combination we will be implement the LL1 parsing table. So if you are talking about LL1 parser, so input buffer is there, where I have already told that input alphabet is there, means collection of input alphabet, input terminals followed by dollar. Then output is what? That is basically we are getting parse tree for output. In stack, grammar symbol is there, bottom end marker is there. Okay. Then we may use, take input alphabet, we may take some start symbol, some other variables. These are the, when stack is empty and only dollar left in the stack, means both dollar is there, then we have to reach the completion process. Then parsing table is what? It is two-dimensional array. One dimensional is a set of non-terminals, whatever non-terminals is given. And this is the set of terminals, whatever E, B, C plus star is given. So this is basically the structure of the LL1 parser. What are the actions? So firstly, we have to see that what actions. It depends upon the stack symbol and current input symbol. Okay. So suppose at one moment, X is the current input symbol, top of the stack, and A is the current input symbol. On the basis of capital X and A, we will decide the further action. So three conditions are there. The first condition is what? If capital X equals to A equals to dollar. So what it means? Capital X means top of the stack is also dollar and current input symbol is also dollar. Then we have to set that the parser halts and successful completion has been gone. Okay. The second condition, if X equals to small a equals to, if capital X equals to small a and current input symbol is also small a. Okay. So top of a stack is one terminal and the same terminal is current input symbol. Then we have to just pop off the input from the stack and remove the input from current input symbol, means this input is exhausted. So the second condition, through that we will be just exhausted the input alphabet and access the input alphabet. The third condition is there, if X equals to one terminal and small a is one non-terminal and small a is the terminal, means it is a combination of terminal, non-terminal and terminal. Then we have to check the entry of table. In table, you are finding that if V and comma A is given, it is given V produces Y1, Y2 up to whatever is given, YK. Suppose number of variables or combinations of variable. What we have to do? We have to replace this Y with this right hand side of the production in reverse order, means Y1 is the top of the stack, Y2 is the second top of the stack, Y3 is the next element inserted in the stack, means reverse order. So suppose if there is a combination is given, E produces T E dash, and at some time $E is there. At next time we have to put E dash T, means capital T is the top of the stack and E dash is the basically second top of the stack. Okay. Then on the basis of capital T and current input symbol, we will again. So these three kinds of things. If we are getting nothing because some combination is there and we are reaching to some blank spaces, so all empty entries are basically treated as error. If during the implementation process anywhere that situation is arise, what you have to do? You have to stop the process and you will just conclude that either the given string is wrong or the process you have applied somewhere is problem, or that grammar is not basically the grammar is not suitable for LL1 parser. So this is the final action, but in between how we will generate the parsing table, because most important thing is the parsing table generation. So this is given here. You will see that it is a stack input and output. Output is the whatever productions you are using for replacing the things. So $S is there. This is simple table is given. This is the grammar is given. So this is table is given. You will see that $S, S and small a. What is the combination? ABA. So ABA is replaced where small a is the top of the stack, then B, then A. Then again, small a, you will see that both the same. So second rule is applied, A is exhausted, A is removed. Then B and B, you will see that B produces BB. You have to replace capital B by small b and small b, okay, where B on top of a stack, okay. Then again B is there, so it is cut. Then again B produces next B. B produces B, again BB. You will just cut this, okay, this is cut here. Then again B and small a, you will see B produces epsilon, B produces epsilon, so B is eliminated, small a is there. Both a is, because the top of the stack and current input symbol is same, so we have to pop this small a from that, and we are getting the dollar at both places. So this process is completion. But the important thing is what? It is the last process. But in between, we have to generate this parsing table, LL1 parsing table. So for generating this parsing table, we have to finding some procedures. Through that, we will generate this table. So we will learn this thing in next. So if you are talking about, we are taking some grammar, this is the parse tree, which is derived by that. You are aware that. So for LL1 grammar, the original grammar, actually this grammar is modified grammar. I will be giving the original grammar for you. The grammar is given in this form. E produces E plus T by T. T produces T star F, IF. F produces bracket of E by ID. The first most important thing is what? Firstly, you have to eliminate the left recursion if it is there. So you will find that in this production, A produces A alpha by beta. Similarly, you will see in that A produces A alpha by beta. So these are two left recursive production. Firstly, you have to eliminate that. And if we are eliminating this left recursion, what is the output grammar after removing this left recursion? That is basically A produces beta A dash and A dash produces alpha A dash by epsilon. So if you are converting it, you will find that E produces T E dash produces plus T E dash by epsilon. Similarly, T produces FT dash, T dash produces star FT dash by epsilon, and F produces bracket of E by ID. So you will see that. So this grammar is converted form. So this is called basically the problems during top-down parser. Whenever you are starting with predictive parser, firstly you have to check in the grammar there is left recursion or any other problem is there. Okay, left recursion or backtracking is there. Okay. How you are getting this table? The most important thing. So for getting this table, you are taking this grammar and finding first of capital X and follow of B. The first of capital X means capital X is a grammar symbol, means terminal is also the first of there and non-terminal is also derived the first. And follow is basically, so these two functions are derived for generating this table. So this is basically the process is given, how you can implement the second grammar, but we are finding the first, then follow. Okay. So what are the rules for first and follow for generating basically parsing table? So coming to the first rule is what? Suppose we are taking that grammar, E produces, in next particular, I hope, yes, this is given. I will be just firstly state the rules. If X is a terminal, suppose, then first of X is X, means every terminal is the first of itself. Okay. If capital X is a non-terminal and X produces epsilon, okay. So capital X is a non-terminal and it derives epsilon, right hand side will be epsilon. Then epsilon will be added in the first of X. The third rule is there. If X is another rule is there. If X produces a small a alpha, then a small a is added into the first of X. This is also one rule. Then important thing, if X is a non-terminal symbol and it derives number of non-terminals in right hand side. Okay. Then firstly, whatever non-epsilon first of y1, that will be added into the capital X. It is getting, suppose we are deriving E produces T E dash, suppose capital T is there and capital T first is already given. So whatever capital T first, non-epsilon first, yani means the epsilon is not there, that all values are just inserted into capital E. Okay, first of capital E. Suppose y1 is derived epsilon, then what you have to do? You have to take this y2 non-epsilon first and add into capital X. Till now yn, you have to check it. Okay. If yn is also derived epsilon, then you have to add, because it is converted into X produces epsilon. So epsilon is added into any left hand side variable only when it is the whole right hand side in the form of this. The right hand side will derive epsilon exactly. And that is the space of confusion. The students are making mistakes to calculating during calculation of first only in this rule. They are every time making mistakes for that. Okay. So epsilon is only added when the complete X right hand side is deriving epsilon. If any one of the variable is not deriving epsilon, then this process is stopped and the epsilon is not added into capital X. Okay. So that is third rule. So if you are applying these, suppose E produces T dash. So first of E, first of T, first of T dash, E dash, F. So firstly you have to derive F produces this one. F produces bracket of E by ID. Simple. So you will check the rule. This is A, this is alpha, and this is F. So small a is added into the first of F. So F's left parenthesis is added up in first of F. ID is also, because F produces ID means X produces deriving small a. Okay. Or any variable. Or you are taking A alpha. Alpha is basically epsilon. Okay. So ID is added into first of capital F. So capital F added ID. Likewise, E dash produces plus T dash. So plus is terminal, this is alpha. That is small a, that is alpha. That is alpha. So small a is added into the first. So plus is added into the first of E dash. You will see that first of E dash. This is first of E dash basically. This is first of E dash. This one. E dash plus is added. Epsilon is also added because E dash produces epsilon. So the rule is X produces epsilon. You have to add epsilon in that. Similarly, in T dash, star is added and epsilon is added. You will see that in T dash, we are getting a star and epsilon. Now we have to check E produces T dash. So in E produces T E dash, if you will see that, the first of T, whatever non-epsilon symbol is there, and T is not derived epsilon. So whatever T has as first of non-epsilon, like multiply, okay, like ID, left, like whatever T is having, because T is not already defined, okay. Then we have to check the first of T, that is derived by T produces FT dash, okay. Then you have to check the first of F, because whatever first of F is there, that is added into capital T, and whatever capital T first is there, that has to be added in capital E. So what do you have to do? You have to check the first of F, and it is equal to first of T and equal to first of E. So first of E is having plus left parenthesis in ID, because F first is going to be capital E and F first is going to be capital T also. So we are deriving the first set using this particular process. For follow, we need first. Firstly, we have to generate the first, because first is needed for generating the follow. The follow rule is there. Whatever start symbol is there, you have to add this dollar in the start symbol of follow of S. The two important rules. If one production is in the form of A produces alpha capital B beta, and beta does not derive epsilon, then everything is in first of beta, is in follow of B. Whatever first of beta is having, that is just added into the follow of B. Okay. The third rule is, if any production in the form of A produces alpha B or A produces alpha B beta, where beta derives epsilon. You will see that if beta derives epsilon, then it is equivalent to this. What you have to do? Everything is in follow of A. Whatever exists is in follow of A, that is directly copied to follow of B. So these three rules applied for finding follow. Now we will come to this grammar. How we will find? We have to write, which is a start symbol. Start symbol is capital E, so dollar is added into the capital directly. Okay. Now you have to find second rule. Second rule is what? If any production in the form of alpha B beta and beta does not derive epsilon. So you will see that. You will write it. Alpha B, you will check it. Capital B, beta. Alpha, capital B and beta. This one capital B, alpha is epsilon, capital B is T and beta is E dash. And E dash is not derived epsilon. Okay, because plus T dash is also derived by that. So whatever first of this beta means whatever first of E dash, that would be the part of capital D. First of E dash is what? First of E dash is right parenthesis and dollar. So you have to add right parenthesis and dollar in the set of capital T. Okay. Then again, if you are taking alpha B beta, whatever having this first of T dash, that would be added the first of F. So first of T dash is having star. Okay. That star would be added in the first of F. Okay. Now come to this. Alpha B beta. The right parenthesis is added in this epsilon. Dollar and right parenthesis. Okay. So this is the use of second rule. Now we have to use the rule third. And it is used 2 times in that. One is alpha B beta, where beta equivalent to epsilon, and second one is alpha B. Okay. If you are seeing that the follow of E will be copied to follow of T. So dollar and right parenthesis is copied to follow of T. And you will see the second rule. Everything is in follow of A is in follow of B. So follow of E is directly copied to follow of E dash. So follow of E dash equals to the follow of E, dollar and right parenthesis, by using these 2 rules. Suppose you are using this, T produces FT dash, that is alpha B beta and alpha B. Okay. So whatever follow of capital T, that would be goes into added into capital F also and capital T dash also. So the follow of T is plus dollar plus right parenthesis and dollar, basically by using that. So this, the whole follow is copied into that. Okay. So T's follow members will be added to T dash and F also. So T dash is having plus right parenthesis and dollar, and F is also having plus multiply right parenthesis and dollar. So we are getting these 2 values, first and follow, both here. Okay. So till the lecture is over, I will discuss the table generation in next lecture. Thank you.